Okay, this is the last video about ionization energy. In this video, we're going to talk about, like this table says, higher ionization energies. Talk about the first ionization energy, the second ionization energy, the third ionization energy, and so forth. So let's just talk about what that means, first of all. Okay, the first ionization energy we already talked about. If we have sodium, and it's a gas, whoops, just sodium, not sodium ion. It turns into an ion when it loses an electron. Okay, that's the first ionization step. So on this table, this is let's call it this, EI sub 1, first ionization energy. Second ionization energy, we start off with the ion, and we still lose an electron, leaving us with a +2 charge. Okay, that's the second ionization energy. Third ionization energy, same thing. We start with that +2 charge, and we lose an electron. Each ionization energy, we are just losing one more electron. Okay, that makes sense. Now let's take a look at this table. And let me draw your attention to the zigzag line or the stair-step line there. So this line right here, okay, it should be fairly obvious, but I'll highlight it anyway. If you notice, as we look in a particular column, say we look just under sodium here, okay? At that zigzag, as we go down, there's a huge jump in energy. That's almost a 10-fold jump in energy, okay? And what that means is the second ionization energy is much, much less favorable than the first. Or another way to say that would be to remove the second electron requires a lot more energy. Now here at magnesium, that second ionization energy is a small jump from here to here, but that third, going from the first to the second, from the second to the third, that's a big jump. And every time we cross from the blue to the pink, we have a large increase in ionization energy. Now let's talk about why that is, okay? And it's pretty simple. Let's look at sodium, the electron configuration for sodium plus. What is it? It's 1s2, 2s2, 2p6, or what's that equal to? Do you guys remember? Okay, I'm not hearing anything, so I'll just give you the answer. Yeah, it's sodium. Gosh. Neon. There we go. I didn't even have the right answer. Okay. And what is the electron configuration for a magnesium ion? An Mg2+, because that's the most stable ion that it forms. And that's where we see that big jump. Well, simply, it's neon. And what is the ionization energy, the electron configuration? Let's erase that. It's the electron configuration for aluminum ion, Al3+. That is neon. So what you'll notice is as you cross the stair step from the blue to the pink, that next ionization energy with a huge increase in energy, that's removing an electron from the noble gas electron configuration. Remember, noble gas electron configuration is stable. So for instance, Na2+, it is not neon. That electron configuration is 1s2, 2s2, 2p5. And magnesium 3+, 1s2, 2s2, 2p5. And guess what it is for aluminum? aluminum 4 plus, 1s2, 2s2, 2p5. So they don't want to form these guys. These are bad. These are hard to form. So it takes a lot more energy to form them. Okay, that's the take-home message here. Please, please, please contact me if you have any questions about any of this. I know you guys can't ask me questions in this format, but we're just going to do the best we can. So next video is electron affinity.